red meat because it prevents red. If red meat, if you went to the butcher shop or you went to Publix and there was untreated and nitrites and sulfites are used to preserve freshness. And meat turns brown unless it's treated with something that chemically prevents that from happening. So, and neither one of those chemicals is really good.
It turns brown because the oxygen.
Because they're red because the hemoglobin is oxygenated, and as the oxygen leaves the tissue, that's what we're eating, you know, cattle tissue, it turns brown.
Unless you froze it as soon as.
Yeah, but even then, it's not that bright red color. By the time you get it all thawed out, it's not the same. Of course, by the time you cook it, it's not the same either. We use preservatives that way to make food look a certain way. All right. Now we're going to talk about some compounds and begin to talk about writing formulas. So we had two types of ionic compounds and two types of acids, which are specialized ionic compounds. So an ionic compound is composed of positive ions and negative ions. The simplest unit is a formula unit and is neutral with respect to charge. We're going to really get into this tomorrow when we do the writing of formulas from the name. The formulas are generated based on the determination of the simplest electrically neutral molecule. That means that sodium chloride. That's the easy one. So I go to the inside back cover of my book and I look up sodium ion. And it says that the symbol for sodium is Na and the ion is +1. And then I go to the inside back cover of my book and I look up chloride ion, not chlorite, not chlorate, not perchlorate, not hypochlorite, chloride. And I see that that's Cl-. So this is a plus charge, and this has a minus charge. The sum of the charges has got to be 0. And in this case, +1 and -1, it is 0. So the formula for sodium chloride is NaCl. It's not Na2Cl2 or some other combination like that. It's just the simplest, which is the lowest possible ratio between the cation, positively charged, and this is the anion. The simplest ratio between the two. That is electrically neutral. And I don't have to write the plus and the minus charge here, because this is a neutral molecule, it's not the ion. And the cations and anions in a compound can be either monoatomic or monatomic, like sodium and chloride, or they could be polyatomic, If I had written, you guys see this from all the way over here? Probably not. Let's see what the next slide is. All right, I'm going to write on this one. I might have said, write the formula for ammonium nitrate. So, go to the inside back cover of the book, and I see that ammonium ion, polyatomic cation, is NH4, and it has a net plus charge. And then I look up nitrate, not nitrite. I look up nitrate, and I see that that's NO3 minus 1. So again, plus 1 and minus 1, that's nice, 0. So the simplest formula is NH4 NO3. But both of these are polyatomic. This is a polyatomic cation. This is a polyatomic anion. Poly meaning many. So binary ionic compounds are composed of one metal ion and one non-metal ion. Monoatomic. Binary meaning two. One of them. Pretty simple. A ternary ionic compound is composed of a metal ion, single metal ion, and two other elements. Usually a non-metal plus oxygen, but not always. It can also be another metal with oxygen or a semi-metal with oxygen. Semi-metal being something like carbon. So you might have sodium carbonate, which is sodium's a metal, carbon's a non-metal, plus oxygen. Or it could be another metal like chromium, and you might have potassium chromate. Potassium is the metal, chromate, polyatomic anion made up of chromium and oxygen. All of these are in the inside back cover of your book. These definitions of these compounds, all 5 of them are going to be on the second exam. Some will be in the definitions, some will be in the true and false, but they're all going to be there. So I would really get into the habit of printing these out. Binary molecular compounds. We spend a bunch of time on these tomorrow because they're not ionic compounds. You can't find, the formulas cannot be found by going to the inside back cover of the book and looking for an anion and a cation because they're not ionic compounds. They're composed of 2 non-metals, and there are no rules like we have with ionic compounds where we're trying to preserve, make sure it's electrically neutral. You can't do that with a binary molecular compound. Binary molecular compound, the formula is determined directly from the name because the name contains Greek prefixes that tell you how many of each element are in the formula. Carbon dioxide has 1 carbon and 2 oxygens. Carbon monoxide, 1 carbon, 1 oxygen. carbon tetrachloride dry cleaning solution. Carbon, 1 carbon, tetra, 4 chlorides. Carbon tetrachlorides, CCl4. So it's in the name. You don't have to go any further than that. If you start going to the chart, you're going to really mess yourself up. Particularly with the first element. Because it's not going to be in the metal ion table. Because it's a non-metal. Binary acids are composed of hydrogen ion and 1 monoatomic nonmetal ion. Hydrogen chloride, hydrogen sulfide, hydrogen plus a nonmetal. Ternary oxyacid, composed of hydrogen and a polyatomic anion which contains oxygen. For example, H2SO4, which is sulfuric acid, or HNO3, which is nitric acid. So it's a hydrogen plus a nitrate, or 2 hydrogens plus a sulfate. The reason this is 2 and this is 1 is they need to be electrically neutral. Sulfate, if you looked it up, would be -2. Hydrogen is +1. We need 2 +1s and a -2 so that they add to 0. Hydrogen is +1 and nitrate is -1 with nitric acid. 2 very strong acids, by the way. The oxyacids tend to be very strong. All right. So I'm kind of finished with this. I'm going to decide. Next week, we have an exam on Wednesday. You're going to need to read chapters 9, the beginning of chapter 9, on moles, and all of chapter 11 on gas laws. Because these 2 chapters are going to be on this exam. Then, on Thursday, after the exam, we're going to do balancing chemical equations, which is sort of the completion of the lecture we're going to do tomorrow. So tomorrow we're going to just do naming compounds and writing formulas. And then the last step, once we learn how to write formulas, is balancing, is to have a chemical equation and balance it. Now, tomorrow's lecture is probably one of the most important lectures for the rest of the term, because everything we're going to do subsequent to this, with the exception of the gas laws, which are self-contained, is based on writing a correct formula. You can't write a correct equation if you don't write a correct formula. And you can't do a correct calculation based on an equation if you start with the wrong formula. So tomorrow is the 6-step method of writing formulas, and we're going to have some fun because you guys are going to get to play outsmart the smartboard. So there'll be, you guys are going to get to come up and show me that you understood the lecture during the class. So I'll know that if you don't show up tomorrow, they didn't want to get called on to come up front and play with the toys. So I don't have anything else I want to do today. Tomorrow's lecture isn't going to be very long either. Thursday's lecture isn't going to be very long either.